the settings that I had before, is no longer here. All right, so that's what working. Okay, it's kind of low. Bump it up a little bit. Okay, there we go. All right. So what we'll do today is, let's see if I can get Scratch installed, because I think it's really great. How many people actually spend some time to look up Scratch and find out how to use it? Did you actually install it and play with it?
My son did.
Okay.
I've been too busy, but we're going to do it together. So.
Okay, well that's good. Let me see if I still have that package here. Scratch. It's not here, so I just have to go to my website and download it again.
Did you fix the dependencies?
I did not fix the dependency, but this is a new distribution, so it has a newer version of Pulse Audio, which was the problem. So I think it will work this time. Let's see, where is it? So we'll go ahead and give it one more try, because I think some of you will find this, at least interesting, and if you play with it, it will help you improve your understanding of the topics that we talk about in this class. So even though it's optional and it looks like it's just useless activity, I think it will still be useful. Yep.
Are we covering it in class?
In class? What do you mean?
Yeah, is that going to be the next module we're going through on screen?
No, it's not going to be. It's completely optional, which means where I'm not gonna. I think it's still in my downloads folder. Yep, it's still here. So let's go ahead and install it. dpkg-i Scratch SSS. There we go. And they got two versions. I think the first one is already here. Oh. Computer is working very hard. Yep.
I was wondering, does it only work with Ubuntu and Debian and stuff? Or does it
No, they have Windows. If you go to the Scratch website, scratch.mit.edu, they have, you can download it for at least Windows. I think there's one for Mac as well.
Okay.
Yep. Let me just go there first. Scratch, C-R-A-T-C-H. So once you download, you will see that you should be able to get it for all of the platforms, all of the popular platforms. So click download, and just ignore this. Continue. So there's one for Mac OS X, one for Windows, and one for Ubuntu. So that should address most of the platforms that people use. It's still complaining. Dependency. Okay, this one wants a 1.09. Okay, let's try the other one. Because I intentionally changed the distribution to use an older version of Pulse Audio. If it doesn't work, it doesn't work. I'll fix it next time. All right. So this is, question number one. I made it so that it looks like a homework assignment, so that you can, when you click on it, you will actually see your score and also how the points, break down. Yep.
I think you're able to override the checking of the versions.
Using
options.
DPKG has an option to do that.
Yeah, you can force to accept any dependencies, even if you don't have them or a proper version.
Oh, it's actually doing it. It's unpacking. Oh, it's still complaining about it. Okay, let's see. Code. Okay, so all the things that we can force. force help. Okay, force help. Okay, force. I think what we're looking for is dependency, right? So look for dependency.
Depends right there at the top.
So turn dependency version problem into warnings. Okay, so that will be force depends version. Nope, that's not it. Unknown force refuse option. Force depends version. Okay, fine. There we go. Because if it does work, it's going to be fun. I mean, this is really quite interesting. How old is your son playing with this? If you don't mind me asking.
Oh no, I have quite a lot of sons, but that one is 14.
14? Okay. My daughter actually started playing with it. You know, I wrote a program to draw a rectangle, and then she started to modify that, you know, to make it draw like pentagons and different colors and stuff like that.
Okay.
Oh, is it still complaining? Setting up Scratch. Yep, it's complaining, but it doesn't, you know, but it's configuring as I request. So very good. You know.
I used it
But
once.
configuring
You used it
anyway.
once?
Yeah. Something was complaining.
Sometimes it's not a good idea to ignore the warnings, but in this
Yeah.
case, I know it's not going to cause any harm because post audio is really just the sound backend of this. I know I'm digressing a little bit here, but for system administration, ignoring some of the warnings that your system tells you can be disastrous. I cannot name the organization nor any names, you know, of this incident, but some people were responsible to manage a server, okay, such as our power server and stuff like that. And at one point, you know, one of the mount points or one of the volumes ran out of space, which is inconvenient. Nobody else can save files anymore, but the system is not crashing because it's running out of space in the user directories. In other words, the system is up and running perfectly fine. It's just that, you know, no one can save files anymore because it just ran out of space. Now, with that particular system, with the right kernel version, you can resize a partition live even when it is still being used, which is a very convenient feature. You can expand the partition size, and then you can make the file system match the new partition size on the fly, just like that. Really, really handy. Except they had the wrong version of the kernel. So the tool comes back and say, whoa, you know, we cannot do this because you got the wrong kernel. You know, I need this particular kernel version to be able to do this. Okay, are you really sure we want to do this? Yes. And then the next message comes back and says, you know, are you really sure that you won't lose your job if you do this? Yes. The next question comes back, are you sure you won't lose your life, you know, if you do this? Yes. Okay, so the system went ahead and actually did it. And the result was, you know, the system is corrupted because, you know, the kernel does not support this operation. So the system started to have corruption issues, which is one of the worst things that you can do. Cannot save new files is not a problem, okay, because it returns the message right away that new files cannot be saved. Okay, it's inconvenient, but everything that you had on the system is still there. Everything is still intact. But now you have a corruption issue. And they did not catch the corruption issue because, you know, people just started to report in and say, hey, my file is corrupted. I could not save this file. What are these files in my folder? My folder is gone. And so after 3 or 4 days, they finally figure out what happened. And then they had to restore the system back to before they did this resize because, you know, the backup after the resize operation, they were all corrupted to begin with. So they threw everybody back to a version of the files like about 5 days before, and obviously people were not very happy. And then guess what? They did exactly the same thing to a different server later on. That was the amazing part, is they did exactly the same thing to another server.
Scheduled downtime.
Scheduled
downtime.
Scheduled downtime.
So they can bring it offline.
Well, but they didn't want to do that because
Well.
people want to go home at 5 o'clock and they want to come back at 8 o'clock. They don't want to, and they don't know how to do it, remotely either. So anyway, I was just saying ignoring warnings sometimes can be a little bit dangerous. But in this case, it's not. It's just hooking up to the back end of the audio. All right. So I think we have that available now as Scratch. And this is fun. This is actually a lot of fun. This is Scratch, the programming interface, or the IDE. It stands for the Integrated Development Environment of Scratch. It does not look like a programming environment. I mean, you have a little canvas here with a sprite, and you can change the sprite too. I think they have a library of these sprites. You can write scripts. You can change the costumes. See, this sprite here has 2 costumes. Basically, if you flip-flop between the 2 costumes, it looks like he's walking. Okay, it's a walking motion. You can also import or make your own, sprites. If you have a camera, I think it can hook up to a camera, but that depends on your operating system. You can also attach it to sound, and I think it should work, with Ubuntu or Debian now. It didn't work. So that's a cat meowing. All right. So now, how does it relate to this class, right? And if you have Audacity, you can play a lot of fun stuff with with sound. You can record some sound, distort it, and stuff like that. So you can just the sound and the sprite gives you a lot of fun already. But where's the programming part of it? Now, if you look at these tabs here, we have motion, looks, sound, pen, control, which is the one that is related to this class, sensing, operators, and variables. Okay, so it has just about everything that we have talked about up to this point. Now, after this point, we'll start to talk about arrays, and then it doesn't have the concept of arrays anymore. But if you just want to practice the loops and the conditional statements, how to combine those things together, it has everything that we have talked about so far. All right. So what we'll do is we'll just go ahead and try something. Let's try to make it walk all the way from here to here. Okay? And walking is a motion. And it is move a certain number of steps. So with a control, you have to start with control. Usually people start with one of these blocks here. Either when the green flag is clicked, the green flag is here. Basically, you're saying, okay, start execution of this program. Or when whatever key is pressed, or when sprite 1 is clicked. So these are trigger operations to start the script running. And you have a few options to start the script running. I'll just use the green flag because it's just easy to click here. Then you just go to motion. If I don't want to do anything fancy, I can just keep a whole bunch of blocks like this. Make it to make it move a few steps. And when we are all done, we can go to control and scroll all the way to the bottom here and say stop script. You can see that I'm just dragging and dropping the blocks. There's no typing. I have not typed a single letter in this interface at this point. Okay? Which also makes this kind of difficult for people who need accessibility. Yep.
So each one of those things would basically be one of those 20 lines of script inside a file. That's what you're saying?
They're kind of a shorthand of something, but it's not quite a subroutine. It's not an abstraction. So now we can just go ahead and run this code, and you can see that, hey, I don't see it taking 5 steps. Did you? Well, that's because all those steps are performed sequentially with no delay in between. So to the human eye, it is so happening so quickly that they are all merged into one single big step, to take 50 steps. Okay, fine. So we'll go to, let's see here. One of these things has a wait operation. So we'll go wait, looks, sound. Is it control?
Yeah, right there.
It's at the bottom.
4th one from the top.
Yeah, fourth one. It's on top.
Wait a second. Okay. You can also change how long it waits. Oh. Now, This part makes it kind of difficult because when you make a mistake, changing the code, takes a little bit of work. But you can see that, the thick white bar here is basically showing you the insertion point. When you drop it, that's where it's. I don't have fine motor skill. Fine, there we go. I cannot be a brain surgeon. The person will wake up and the left and right is flipped. It's like, oh, sorry. Back onto the table. Okay, so now I have move 10 steps, wait a second, move 10 steps, wait a second, and so on. So we give it a green flag, and it's basically crawling across the screen. Okay, no big deal. And to make this even more fun, we can change the costumes. Okay, so I think the costume belongs to looks, and we can always use Nick's costume here. So we'll change the costume after waiting, and we'll just stick it here. Oh, is that the right place? Yep. And stick it here. And one last one here. And then we'll just run the code again. See? Now Scratch is running. Slowly. In slow motion. Okay, we have the matrix special effect here. So, you can see how easy it is to put something together. But right now, it is boring because, if I want to make it go, another 5 steps, I'm just replicating these blocks. There's no fun doing this. How about we make it so that it will take a number of steps using a loop? Okay, we can use repeat, but let's use only the constructs that we have talked about in this class. So what that means is we have to go to the control tab here and then look at these things. We don't want to use forever because forever means it will keep doing this forever. But you know what? Let's try that first, okay, just to see what it looks like. So to introduce a loop, okay, we have to separate the block out here, and then we can remove all these ones. And this is the block that I want to repeat. Let's stick it inside a forever loop here, and then stick this here. And obviously the end script, block is not useful anymore because we are not stopping. So we'll take it away, just like that. And it's crawling a little bit too slowly, so we'll say, only wait 0.2 seconds. So it will actually take 5 steps per second. Then we'll make it kind of like walk really, really fast. Okay, so we'll reset the position of the sprite and start the execution. It's galloping. It's galloping, it's galloping, it's galloping. And now it hits a wall, and it's still galloping. Cluck, 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 like that. Alrighty. Okay, so it's not stopping, right? If it's not stopping, let's change the code here a little bit here. We don't want forever anymore. What we want is, well, there are several things we can do. There's a repeat until, and there's also another loop. Repeat number of steps here. This is a shorthand. We don't have that concept in this class. So we'll go ahead and just use repeat until. And in this case, repeat until checks the condition first. Okay, so it's not really quite matching our own repeat until. This is a pre-checking loop, not a post-checking loop. And we'll go ahead and stick this stuff back inside it. So the question is, when do we want it to stop? Well, let's go to sensing and see what we can sense in this case. Okay, so there are several things we can sense in this case. When it's touching something, so and you can see what you can do. You can say that when it's touching edge, it's a condition, right? So we'll go ahead and move this block. Now you can also, I'm not sure whether you guys can see it or not because it's hard to see the shape. Can you see that there are different shapes?
Yeah.
Like this shape here. What is this shape? How do you describe that shape? It's a hexagon. Okay, and this shape is also a hexagon. So the shape dictates what can go into what else. That's your syntax. Okay, that's the syntax. It tells you that we need something that's also a hexagon to go into this hexagon slot here. So now we can say repeat until, oh, okay, not yet, not yet. I meant to click the drop-down box here until it touches the edge. Okay? So there we go. And we'll make it run again, literally. And this time it will stop once it hits the edge. Ding! It stops. Okay? Now we can make it more fun and make it turn around when it hits the edge so it can go back to the other way. Now to do that, we'll change the program structure one more time. And we'll take this stuff out. We'll remove this block here. This time we'll go back to a forever. Okay, because we want it to bounce back and forth in the forever. So we go to control and then we put the forever loop back here. But we also need to put some code here to detect whether it has hit the edge or not. If it has, then we turn around. And what kind of statement are we using in this case? If then statement is also called a conditional statement. So we'll go ahead and pick up a conditional statement down here. And there are two types of conditional statements. One is an if and one is an if else, corresponding to our if then and our if then else statements. Now in this case, we don't have anything else to do, so we'll just go with a regular if. And we'll go back to sensing again and say that if it's touching the edge, we'll do something. What are we going to do? We're going to turn around. Okay? So to turn around is a motion, and we can use the turn or point in direction. Both of these will accomplish the same thing. It's just that one is specifying how much to turn, and the other one is telling you which way it is facing. So it's up to you to decide which one you want to use. And also, if on edge bounce, that's kind of interesting too. Why don't we just try this one out and see what it does. Okay, and then we just move this block the entire block back into the forever loop and start the execution. And it will just keep going back and forth like that. Because what bounce does is it will just turn it 180 degrees. Okay? Are you guys following? Okay. Now how can we turn this into something a little bit more interesting? How about having Scratch to follow the mouse pointer? Does it sound like a lot of work? It's actually pretty easy. Okay, so in that case, what we want to do is let's take this block out, take that away, and then we'll go to motion again. And in motion, there's one point towards. Okay. You can see this is a point towards, and then you can specify point towards the mouse pointer. When we have multiple sprites, the drop-down box would actually let you select the other sprites. In other words, you can have one sprite to follow the other sprite. If one is moving in a certain direction, you can make the other one to mirror in the same direction. Okay? And we are not going to try anything too fancy here. We'll just go ahead and run this program. And see, whenever I move my mouse, Scratch is following it.
Cat chasing the mouse.
All right. So now we can make another sprite. Let's say you can make a mouse, sprite. So we go to sprites here, and then we make a new sprite. Let's see if there are any selections here. You can see that there's it comes with a big selection of sprites already. And let's see if we can see cats. Okay, mouse is M, so we go all the way down to M. We got monkey. We got only one mouse. Oh man, just one. Fine, we'll just use that mouse. The mouse is a little bit big, and it doesn't come with any costumes, which means we cannot make it make the walking motion. That's fine. We'll just go ahead and use this one. Now, what you will see is, okay, look at the scripts part here. If I click on a different sprite, you can see that it changes. What does that tell you? Each sprite has its own scripts to follow. Okay, so in other words, as a programmer in this particular situation, you're kind of like you're writing the scripts for all these actors. And guess what? The backstage has its own script to follow. So you can even control the background, make it change the background, responding to, events that happens here. So let's go ahead and look at sprite 2, which is our mouse here, and write something here. So we'll go to control, use the same starting point when the green flag is clicked, and we'll stick it into a forever loop. And we'll also make it just move steps, okay, 10 steps at a time. We have to make the cat move a little faster so that it can actually catch it.
How about the mouse catches the cat?
Hmm?
It's bigger.
Oh, I can control that too. Let's see here. Change color, say thing clear. Change size by. So we'll stick it, stick this code here, and then we say change size by -50. Okay. Now, if you want to find out, what it does, you just click it, and it will do it. See, change by 10 is making it 10 pixels larger. So if I change size to percentage is even better. So I can specify that. All right, fine. Take that out, put that in. Let's make it 50%. 25. So we have a smaller mouse in this case. And you can test the script just like that.
Oh, yeah.
All right. So the mouse is walking rather fast because I don't have a delay here. Okay, so the next thing we want to do is to put a delay. Oh, is it under control? We put a wait here. And you can see that I can do this, the whole class, because it's really so much fun. And we have to drag it back. Catch it. Catch it. Ooh, yes. But nothing happens because there's no code corresponding to what happens when those two sprites collide, right? And the mouse is also walking in one direction, which is not very fun. So what we'll do is we'll introduce some randomness into this whole thing. So we'll go ahead and put a turn into the mouse. And in this case, it's always turning 15 degrees. So we'll see what happens when we execute this code. The mouse is just walking in a circle. Because for each step it takes, it's also turning 15 degrees. And it's doing it forever. Okay? It's not a whole lot of fun this way. Fine. We'll change this so it's not 15 anymore. Let's make it random. Random belongs to, I believe, operators. Pick a random number from a certain number to another number. So you drag this, this is a kind of like a rounded end, and this is also a rounded end slot. So you can put this into here, and we'll just say from -10 degrees to +10 degrees. So now it's going to go squiggly on us. All right, so that works. And we want it to bounce too, when it hits an edge, we want it to bounce back. So we'll have this code here too. That makes it a little bit more fun. Catch, catch, catch. Oh, but nothing happens here, right? Because I haven't written the code to say what happens when those two collide. All right, so we can do a little better. Okay, so let's stop this code here, and we can switch back to Scratch, the Scratch script. And what we can do is we can check the condition. Okay, are they colliding? So we'll go ahead and put in a conditional statement. And in the condition here, we specify touch. And you can see that the options here, I have now a new option because sprite 2 is also one thing that the sprite can touch. So we'll specify sprite 2. Okay. And what do you want to do when the cat catches the mouse? Let's make it say something. Okay. First of all, let's go to sound, and we'll play the meow sound first. And then we'll go to looks, and we'll say something. Okay, we'll say dinner is served.
Awesome.
For 2 seconds. And we'll run the code. All right, so come on, catch, catch, catch. Ding! Dinner is served. Okay.
But the mouse keeps on moving, you have to make the mouse stop too when it's being touched.
It's a reincarnation. The mouse is an undead, it just keeps coming back. That's why it's green too. Okay, now what about variables? The program has not used any variables at this point. What about we keep scores? In other words, we keep count of how many times we have caught the mouse. Does it sound like something that a game might need to do? So what do? We go to variables. And there are no variables to begin with. So the first thing you need to do is to create your own variables. So let's go ahead and make one. And we'll create a variable. And you have an option, whether it is local to the sprite that we are dealing with. In this case, it's the cat. Or whether it is available to all sprites. So let's just say this is available for all sprites. And we'll just call it score. This is the first time I actually have to type something. Well, other than changing the numbers and stuff like that. Okay, so now we have a variable. Now for every variable that you create, you will see these 4 additional blocks. Well, you will see a block here, and now we also have things that we can do to variables. The first thing we want to do to a variable is to set the score to 0. Okay, so we want to reset it, and we have to stick it before the forever loop. Otherwise, it will be resetting it to 0 every single time it gets around. And then we want to change the score by 1, which means increment by 1, when we have caught the mouse once. Okay, and that's all you need to do to keep score. So let's go ahead and run the code. Yee-hee. Come on. Okay. So you can see the score is now 1. And we'll catch it again. 2. And so on. So you can see how I can build a program step by step. And it's kind of fun too. You can also look at the background. If you click stage, you can see the stage has its own script to follow. Okay, so if you want your script to do a particular thing, this is your chance. Go ahead.
And later you can make it full screen when you're ready. You're satisfied.
I'm not sure whether you can make it full screen.
Yeah, you can.
You can. Oh, you mean this one here? Presentation mode.
Yeah.
Oh yeah. Okay, but there are other things I might want to do, because I might want to make this game not forever. In other words, I'll give you like 30 seconds and you have to catch the mouse as many times as you can. And I might even want the mouse to go a little faster each time you catch it once, so to increase the difficulty. How would you do that? Just to make the mouse go faster every time you catch it. Well, what we need to do is to change this number here so that it does not okay, this we have to keep, but the way we set up the number of steps, we can change that. We can also change the delay. Right? And I'm looking at the wrong one. I have to look at this one here. So instead of moving 10 steps, I can now say, I want to make it relate to the number of times you have caught it. So it has to relate to score. So we can make it 10 plus what, 3 times the score. Okay. And I cannot type it because when I type the multiplication key, it doesn't really do anything. That's because operators have their own special icons. So now that I have to do something like that, I have to. It starts with an addition on the outside. Okay. The first thing we want to add is at least 10 steps per 100 milliseconds. And then the second one is our score. So now you can go to variables, and then you can just add score to it. So now every time it moves, it's going to move 10 plus score steps. It will start with 10, and then 11, and then 12, and so on. But let's just say that you feel that this increment is too slow, it's not increasing the difficulty of the game too much. Well, let's take score out, go back to operators, use the multiplication symbol, stick it here. We stick variable, put score on one side, and I'll just type 3 on the other side. Okay. Okay, so now it becomes moving 10 plus score times 3 steps. It will start with 10 steps, then it will go to 13, 16, 19, and so on. Okay, and well, let's find out whether it works or not. This is just a solid excuse so that I can play. Whee! Is the mouse moving faster now? Okay, now how about we make the mouse go in the opposite direction instead of moving in random directions? It's actually trying to evade the cat.
Awesome.
Okay, how do we do that? See, this is problem solving. You are trying to increase the difficulty of the game by introducing just one thing at a time, So now we're trying to make the mouse evade the cat. Okay, so how do we make the mouse evade the cat? Well, obviously we have to choose something from motion, and it only has point in direction and point toward. It doesn't have say point away. But if you can point toward, it's easy to flip it, right? You say point toward, and then you turn it around to point in the opposite direction. Okay? So what we want to do is after we catch the mouse, okay? So now the mouse, which is this little guy writing this code here, also need to detect whether the cat is touching it. So once again, we go to control, we introduce a conditional statement, and we'll stick it here. Oops, that's not what we want. And it's just running this code here. Stop. All right, so we'll go back to sensing, and we'll go back to touching. If it touches the cat, we'll do something. The first thing we'll do is we go to motion, and then we'll say point toward the cat, and then we'll go point away from the cat. In other words, we'll point, we'll turn around, and let's make it more fun. So instead of just pointing away 180 degrees, we'll introduce some random factor to it too. So we'll just say this is going to be operator. We'll use a plus symbol here, and 180 plus a certain random number. Stop. Okay, pick random number. And this time we want a wider range, so we'll say negative 45 to 45 degrees. Like that. And now I can cheat because I can move the mouse. I can move the cat like that. See, the mouse is now running away, but it's bouncing between the wall and the cat, so it's caught. Chase. It's a slower cat and a faster mouse. So you can see how I can spend a whole class just doing this, making it more fun, and you can change the background too. So depending on the score, you can make the background different. Okay, bloodier or something like that. Whatever. So I'll just go ahead and show you what you can do with the background. Now, in the background, there's no motion because the background is just the stage. It doesn't move. But you do have pen looks, and you have pen as well. In other words, you can change the background. Okay? And you can also go to the background tab here, and you can make new background if you want to. So we'll say, let's go ahead and make a new background, and you can import it. And it has a lot of nice backgrounds already. Oh, nice.
The desert looks good because it's cartoonish. So it's in the background.
Okay, fine. We'll paint. All right. So now you can paint your own background. Okay. So you can draw a mouse. Disney is gonna sue me. Just that is enough to get me sued. They will say, "Oh, this is trademark. This is this is Mickey Mouse." Yep. And we'll make a crossbow like this. socket, nose. There we go. Of course, the ears won't be there. I mean, the ears will be the first to go. Okay, and we'll just go ahead and paint that red. All right.
Make the
Yeah.
make the eyes X's.
Make the eyes exits. Okay, but this is the background scripts. Okay, so what I can do now is go back to script. So I can say, display this, but only when I have achieved, 5 points. Okay, so now we can go to the background script. Same thing, the background script will start when the green flag is clicked. And the first thing it will do is to clear the background. So we go to looks, we go to switch to background, and we switch it back to background 1, which is the blank background. And then we'll stick itself into a loop. We go to control, and we'll see what is appropriate here.
You can add personal sounds, right, to the background.
Oh yeah, you can add sound to the background too. So they're all independent. You can see how this is all going to be kind of fun. Let's see what would be a good one to use here. Wait until. Go ahead.
You could save all that to your own thing and bring it back and work on it and save it. Or I'm sure you could.
Oh yeah, you can save everything. You can actually post it if you register as a user at scratch.mit.edu. It's kind of like a YouTube. It's a community sharing kind of thing. So if you think you have a really cool game that's kind of fun and you want to share with the rest of the world, you can do it. You can export it and share it with the world. Yes.
Can you is the only way to export is actually use Scratch software to play it, or can you export it where you?
When you export it, I believe it becomes a Java program.
So you just put it in any computer.
I think so. I'm not 100% sure about that. Okay, so what we'll do is we'll have a comparison operator because we are waiting until a condition is true. So we'll go to variables and we stick score on one side, and we'll stick maybe 2 on the other side. So wait until the score is greater than 2. Then we'll go to looks again, and we'll switch the background to background 2 with the skeleton of the mouse, and we'll go to control. And this time we'll go ahead and stop the entire program. In other words, once you achieve 2 kills, or once you achieve 3 kills, then we'll stop the program. And we can even go to looks. Nope. All right, I think that's good enough. You can go to sound, and we can see if there are any interesting sounds here. Just pop. All right, that's fine. Okay. You can go to sounds, and I think you can import all kinds of different sounds too. Oh yeah. Let's see. What would be a good sound here? Oh yeah. Special effects, car passing, human, finger snap, cough, laugh, party noise, scream, female. Yeah. All right. So that's what we want to do. There we go. All right. So now we have a program. And you can see the background cleared because we set it to clear first. So we catch, oh, it touched it, and the mouse. Okay, come on. Ah. 2. Okay, one more time. Run, run, fat cat. But it didn't play the sound. I think it needs a delay.
You need to wait after the voice.
Yeah, because otherwise, I play the sound and it stops the program immediately. It doesn't leave it enough time for that sound to actually play out. Okay, so we'll go to control. Wait a second. Okay. Yeah, this is just a sorry excuse so I can play a game when I'm supposed to teach a class. So there you go, and it stops the whole program too, because the last portion here, it says stop all, which means it's stopping all the sprites. Every single concurrent thread is stopped at this point. So this is Scratch, okay, and you can see that programming is not boring, it's not dry. It can be a lot of fun. Okay, yep.
Can we take a look at some of the other ones and like analyze to see what kind of stuff they've used to
Yes.
the other games?
If you go to the web, okay, let me save the file first. So you can save the file, and it has its own folder to save your projects. So we'll say cat catches mouse. Okay. And if you look into file, it has export to, import, export, and also save as. Nope, that doesn't do anything. Import project. So you can download a project from somebody and import it into the project. Share this project online. Go to the Scratch website. So this is how you do it, and you can specify all these different things. You can tag it. You can set up. You have to set up an account first, and then you can export it. You can just put it onto the scratch.mit.edu website so other people have access to your project. Now that we have this all set up, you can look at what other people have done with Scratch. And this is a spiral graph. Okay. Oh, I don't have the Java plugin. It should have the Java plugin. Oh.
At the top this time.
On the top. Yeah, we'll just run this time, just in case someone writes a virus using Scratch. Whoa. Press N for different color. Ooh, N. So I'm just holding down the N key so you can see how I can make kind of like a rainbowish color. Ooh. Cool. Okay, this is a virtual piano and piano chords. Virtual piano with piano chords plays songs using piano chords. Okay. Remember, these walls I built well, but alright, fine. Now how do I click?
Oh, wow.
The numbers are chords.
1, 2, 3, 4.
It's L, A. Yeah, numbers are chords. You just push the numbers.
Thing on the keyboard.
Hmm?
You guys press on the keyboard.
Yeah, I am pressing on the keyboard. It's not working though.
Press play maybe. Maybe press the start.
Oh, the start at the top.
Oh, there's the flag.
Flag.
No, that's just starts from the beginning. It's not playing. 7.
Commands disabled.
Hmm?
Says no sound bank.
Oh, okay. Note and drum commands disabled. Oh. Okay. Okay. You ready? Let's go. And you can see the code too. You can actually download the actual code of the program. Oh, this is supposed to be a song too, I think. I don't know. Anyway, so I challenge you guys to write the Hangman game using Scratch. That's your brain teaser for the rest of the semester. Because the Hangman game seems pretty easy, right? But to code it in Scratch is actually not that easy. Okay? So, and in order to do that, you have to understand some concepts of arrays first, because that's the only way you can go through the spelling and then look for specific words, look for specific letters. Yep.
Would the background just be the dude and one more thing? It would go to a new background every time?
You can switch to a new background every single
And
time.
that would be the guy hanging with half a head, full head, body, arm.
You can, well, there are several ways you can make the sprite do it too. You can have different costumes for the sprite.
Different costumes.
Yeah, so you start with the full Hangman, and then you delete items, and then save each one as a different version.
Okay.
So you can do it in many ways if you want to do the Hangman game.
So you're just drawing your own sprite, you're saying?
Yeah, you have the canvas to help you draw your own sprite. You can do it in the background too. You can do it many different ways. Then you have to record the actual hanging sound, the rope tightening and all that stuff. The thumb like that. But you still have to make sure it's rated G before you upload it to this website. Anyway, well, I'm hoping that some of you will find this interesting. But it's a really great way to experiment with programming logic. Okay, because nothing is going to blow up, unless you program in the background to display an explosion and play the sound of an explosion too. But it's a lot of fun. You can make your own game using Scratch. Not very complicated ones, but simple games. You don't have to understand any syntax. Where's the syntax of Scratch? You have to recognize the shapes, right? The hexagons are booleans. They can either be true or false. The rounded ones are basically any value, mostly numerical values, and so on. So it's really quite fun, and to make any really complicated games out of it, will be kind of involved. It's kind of involved. All right. So we are now done with this portion, and you have a new homework assignment. Yeah. Oh, someone has turned it in already.
Yeah.
Alrighty, I am impressed. So as I was demonstrating Scratch, someone is doing the homework on the cell phone and turning it in already. Mm-hmm. All right. So this homework assignment has got 4 sheets that you have to deal with. It's the homework that I promised you guys last time, but I forgot to actually assign it. So this is the original code of finding a prime factor in n. This is the modified version. It should get out sooner. And this is the test case. Run it with the first algorithm using sheet 3, and run it with a second algorithm using sheet 4. And then you will see how quickly you can get out of the loop using the new code compared to the old code. Yep.
So just 3 and 4 are the actual traces we're working. 1 and 2 is just showing what we're supposed to use.
Correct. 1 and 2 are the algorithms. 3 and 4 are the actual traces.
Okay.
Yep. And then the instruction is here as well. Sheet 3 should capture the trace of the algorithm listed in sheet 1, and then sheet 4 will capture the trace of the algorithm in sheet 2. Shouldn't take too long. It's stuff that we have talked about already. Okay. Any questions about the homework assignment? Not counting that person who has turned it in already. Nope, no questions? Okay, if there are no questions, we are moving on to arrays. Okay, so we'll go ahead and get started with arrays. All right. The whole thing about arrays is there are certain things that will become really hard to do if we don't have arrays. Can we find the maximum of 2 variables using conditional statements and variables? Sure, we can do that. I mean, and I'll just go ahead and show the code to do it. It's no big deal. There's no need to copy this because we have talked about this for many times already. And I almost forgot the row sheet. I can see all the empty seats around you. All right. So to find the maximum of two variables, we can do something like this. If x is greater than y, then z, which is our maximum, is going to be x, else z gets the value of y, and if. Pretty easy. Do we know how to deal with three variables?
Yes.
Yeah, we have talked about that. If x is greater than or equal to y, and x is, oops, let's start with w. X and w is greater than or equal to y, and w is the maximum. Else if x is greater than or equal to w, x is greater than or equal to y, then x is the maximum. Else we only have one left, which is y, and if. Now, based on the three variable case, can you make it work for four variables?
Yes, it's just going to take more code.
It takes more code, 5. You know the pattern, okay? We know we can make it work. What about 30,000 variables? It's a lot of code, okay? Well, not only is that code long and tedious, it's also very brittle. It's brittle in the sense that if I say, oh, by the way, I have one more variable, so now it's 30,001, adding that one more variable will change a lot of the original code because you have to modify every single line and add one more case to the end. Okay, so that means, well, this approach of doing things works okay when we're dealing with a small number of variables, but it doesn't scale up. Okay, as we increase the number of variables, it just doesn't work properly anymore. And that's why we need arrays. I'm not going to explain the notation at this point, but using arrays, we can simplify the code to something that looks like this. Don't ask any, oh, go ahead. Oh, okay. Don't ask any questions about the notation at this point because I will explain the notations while I is less than bar, a bar 2. And I need one more thing here. If a bracket I is greater than m, then m gets a bracket I. If I gets I plus 1, and while. All right. Don't ask me about the notation again, because I will explain the notation. This code, using the concept of arrays, is going to work when you have an array of one item, meaning one variable. It will also work when your array has 30,000, 300,000. The length of the program does not change. The amount of time it takes to finish the algorithm will change, obviously, depending on how many variables we have. So this is the nice thing about using arrays, is something that we can do, but it doesn't scale up, suddenly becomes very simple, and the solution is elegant. Okay, it will work with 1, 2, 5, 30,000, 2 billion, and so on. The code does not change. Are we doing okay so far? Okay, so now let's take a look at what is an array. What is the concept of an array? I'm drawing this on the whiteboard, but I'm describing that too, so the audio would actually capture the description of what I'm drawing. So far, with individual variables, we have coffee mugs. Okay, a coffee mug represents a variable. It is kind of like a good visualization because it's a container, and yet the level of liquid inside the coffee mug can change, and that's why it's a variable, because the content inside the cup itself can change. And at this point, we have individual coffee mugs. In other words, we have one that has a name of X, one that has a name of Y, another one with the name of Z. So in your program, you can refer to, oh, I want to take a look at the content of coffee mug X and compare that to the content of coffee mug Y, and so on and so forth, because you are referring to each coffee mug by its name. Are we doing okay so far with the analogy? This is what we have up to this point. So when you have 30,000 coffee mugs, the first thing is, how do we come up with names for those 30,000 coffee mugs? right? Because X, Y, Z obviously is not going to work. So with arrays, the concept is a little bit different, but very similar to this. With arrays, now we have boxes. We have the concept of a box. Okay, so here we have a box here. And the box has a name, because we need to say, oh, we are referring to that box and not that box over there. So the box itself has a name. Let's call this box A. So now whenever I say A, I refer to this box. Other boxes have different names. But the whole concept of an array is inside a box, now we can put coffee mugs. So inside this box here, we have 3 coffee mugs. 1, 2, and 3. But the coffee mugs don't have names anymore. Instead, they have numbers. Inside the box, the first coffee mug is labeled 0. The second coffee mug is labeled 1, and the last one is labeled 2. Are we doing okay so far? How do I refer to a single coffee mug in this case? I need to refer to 2 things, right? First, box A, and then we have to refer to the number on the coffee mug. So whenever I want to refer to a single coffee mug, now I have to say which box, and then the number of the coffee mug inside that box. Are we doing okay so far? Let's say we have another box here. This is B, which is also a box. B only has 2 coffee mugs. How do I label those 2 coffee mugs inside box B? 0 and 1. Okay? So there's no problem of labeling this coffee mug as coffee mug 0 and this coffee mug also as coffee mug 0. Why?
Different boxes.
In different boxes. Exactly. Okay? Are we doing okay so far with the concept? Now you do have some rules to follow. The first rule is we start with 0. That's quite insane, right? I mean, why would anyone count from 0? We say 1, 2, 3, 4. Okay, we don't say 0, 1, 2, 3. So why do you think, in programming, we start counting from 0?
It's a placeholder.
Go ahead.
It's a placeholder.
It's the actual reason why we start counting from 0 won't be clear until cisp300, but it has to do with internally how things are represented. Yep, go ahead.
I would say because of binary.
No, that is not it. That is not it. But it's a good guess, because in binary we do have 0 and 1. But counting from 0, is because of efficiency. It also has to do with how things are represented inside a computer. So in cisp300, that will become very clear why we start from 0 when we count objects inside the box. Are we doing okay so far with this picture? Okay. So if I want to refer to coffee mug 1 in box A, well, I can say it, but in terms of programming notation, saying all that stuff, coffee mug 1 in box A, is kind of long and tedious. So in programming, we just say A, open square bracket, 1, close bracket to mean that. The name of the box, it's outside of the box. Then you have the box, which is in kind of square brackets. And then you place the number of the mug you want to refer to inside the square brackets. This is called an indexing operator. We're indexing into an array. Same thing here. If I want to refer to the coffee mug 0 in box B, we say B, open square bracket, 0, close square bracket. This is one of the very few instances where if you use the wrong parentheses, I will actually mark you as wrong. Yep.
In this class, are we going to go through multi-dimensional arrays?
Multi-dimensional arrays are very easy to explain because you just have boxes inside boxes.
Right.
Yep. So I can actually draw that picture, as soon as I'm done with these items here. Yep.
Would the other box go inside a cup or the first box?
The cups are, you cannot put a box inside a cup, but you can put boxes inside boxes. Okay? So are we doing okay so far with this notation? The square bracket notation, which means I'm referring to a single item inside a box. Okay? There's another notation. The other notation is bar A bar, And in this case, it is not the absolute value. We cannot take the absolute value of a box. Okay? Bar A bar means the number of items inside a box. In this particular case, because box A has 3 coffee mugs, we'll say bar A bar equals 3. In this case, the box B has 2 items inside, so bar B bar is going to be 2. It's just the number of items inside a box. If you want to remember this, you can kind of imagine that a bar is kind of like measuring the width of something. So that's one way to remember that. Yep.
If inside a box, say there was 2 items in another box, would you say there's 3 still?
Say again?
If inside one box,
Mhm.
there's 2 items and a box.
No, you cannot have that.
You know how that-
Okay, that's a very interesting, that's a good point. Everything inside a box must be of the same quote-unquote type. You can have a box with all coffee mugs. You can have a box with wine glasses. You can have a box with other boxes inside.
Okay.
But you cannot mix and match and say, oh, I'll have like 2 coffee mugs, 1 wine glass, and another box. You cannot do that. Okay, that's a very good point. They have to match exactly the same type, even though the content can be different. In other words, in this case, these 3 coffee mugs can have a different level of liquid, but they must be all coffee mugs, the same size. Okay, so since you mentioned multi-dimensional arrays, we can just explain that really quickly. A multi-dimensional array sounds kind of complicated, but it's really not. What we're going to do is we'll draw a box here, just like the boxes that we have over there. 3 coffee mugs inside this one. Okay, we'll draw a box exactly the same size as the first one with 3 coffee mugs inside, and just for the heck of this, we'll make 2 more boxes like that. So now we have a total of 4 boxes, and each one has exactly 3 coffee mugs in the inside. Okay, so now we have 12 individual coffee mugs separated into 4 boxes so far. Okay. Now in the first example, each box has a name. Let's just make a twist here so we don't name the boxes. The coffee mugs are always numbers 012, 012, 012, 012. But guess what I'm going to do in this case? I'm going to number the boxes too. So this box will be 0, 1, 2, and 3. The reason why I'm numbering the boxes is I'm going to make a big box to contain all these little boxes. So now I draw a big box like that. The big box contains the 4 smaller boxes, and I'm going to call the big box A. In other words, only the largest, the outermost box needs a name. If you have boxes inside the boxes, those smaller boxes will be numbered. There was a question back there.
That's what I was going to ask. No, thank you.
Okay.
Do all the interior boxes have to have the same number of variables?
Yes, they all must have the same size. In other words, the box 0 inside A, box 1, box 2, and box 3, they must have exactly, in this case, 3 items inside. Yep.
So in multiple dimension, like you said, there could be multiple boxes named 0. Because there could be a box, let's say, if instead of A, you name that 0.
Yes, we can expand this concept. Exactly.
Like
So,
mother, let's say.
yep. It's just like packaging containers. You can basically put these bigger boxes into an even bigger container, but then you cannot have a name for each box. They must be numbered in that case. Yep.
So in theory, if there was a box B that had a bunch of little boxes inside it, like boxes with 2 cups in it, for example, that could be box B.
Okay.
That's possible to have A and B in this example.
Yeah,
Yeah,
sure.
but it'll be different.
Absolutely.
Different box. It won't be.
Yeah, because A and
related
B
to
are
box
different
A.
boxes, so what they contain can be entirely different.
Okay.
Okay, now the question is, how do I refer to a specific coffee mug in this big box A? In other words, how do I refer to, say, this one here? Okay? Well, actually, this is not a good example. Let's take this one here. Okay, how do I pick this item? How do I name the item that I have just highlighted?
Square brackets.
Well, first of all, we have to start with the outermost box. What is the name of the outermost box?
A.
A. Okay. Now, every time you use the square bracket, you can only look into the box once. Okay. So, what number should I put here to refer to the box that contains the mug that I want to access?
1.
1. Very good. Okay. So, what exactly is A bracket 1 in this case? It's a box. Okay. It's a box with how many items inside? 3 items. And if I have a box of 3 items, can I refer to just one of the 3 items? Yeah. And it's called an indexing operator. So now I can apply another indexing operator and refer to the last one in that box. So A bracket 1, close bracket, open bracket 2, close bracket will refer to the coffee mug numbered 2 inside a box that is numbered 1 inside the biggest box called A. Yep.
Something to be grouped together, it has to be consistent. Like it has to all have 3, right?
Correct. Yes. The shape of each inner box must match.
Okay.
Okay. Now I know I'm running out of time. Well, we have 5 minutes left, which is plenty of time. But why is array so useful? I mean, all we have introduced, not counting multi-dimensional array, which is kind of like something that I threw in because somebody asked that. And I think it's really easy to understand it once you understand that a box can contain other boxes. But why is this? What is this buying me? I mean, the notation is kind of interesting. Yep.
I was going to say it allows you to scale to whatever scale you want.
But why? What makes it possible?
The fact that we have a system set up that we can recognize.
The fact that these are numbers. Okay. Yes. Go
I was
ahead.
going to say, you don't have a defined set. It allows you to be dynamic. It allows you to grow, expand, and contract as the
That depends on the
scenario.
programming language. In some programming languages, the boxes are fixed. So once you say this is a box of 20 items, you cannot make the box bigger or smaller. So the power of array is that in some languages you do have the ability to change the size of the box, but arrays is useful not only because of that. The most basic advantage of using arrays is, go ahead.
You can say, you can make it start from 0 and go all the way through with one of the +1 things. While
Exactly. So you're
until
getting
it
close.
ends,
Yep, you're
until
getting
A
very
ends or
close.
whatever.
Whatever appears between the square brackets only has to be
A number.
a number.
So you can do mathematical operations.
Exactly. Okay? That is why arrays are so useful. This is just an example. A square bracket 1 is just an example. Okay? That works. The next example is A bracket I. In other words, every time I changes, that will also refer to a different element inside the array. Okay? Element is just a technical term to refer to an item inside a box. Okay? So in the analogy, I say a box, but in programming code we call it an array. In the analogy, each item inside a box is a mug or another box, but in programming terminology, it is called an element. That's the only difference. Okay? And what is stopping me to say, A bracket, 2 times I plus j, the whole thing, minus k, square bracket?
Nothing.
Nothing. Absolutely. Okay? So that means instead of using a constant 1, 2, 0, and so on inside the square bracket, I can turn it into a reference to a variable I. And I gets incremented, for each iteration of the loop. Okay? That's useful. But I can also make it any type of expression as long as what? As long as the expression gives me an integer, and the integer goes between 0, which is the index of the first element, and bar a bar minus 1, which is the index of the last element. But as long as that expression gives me an integer within that range, it's okay. I can put it inside the square bracket. What about something like this? Can I do something like that? Well, as long as that requirement is met, there's no problem with this kind of construct. As long as a brackets 2 gives me an integer that can be used as an index, I have no problem with that. As long as this gives me an integer within that range, I have no problem with that. As long as this gives me an integer within that range, there's no problem. And you can see, how things can get very interesting when we use arrays. And this is just an example, but I can set up a case where this can work. Okay, I just have to set up an array where the values of each element is always inside the range of 0 to bar a bar minus 1. Are we doing okay so far? Are we kind of feeling why arrays are useful in programming? I mean, if you get that out of this class, we are good for this class. Is to understand, just overall speaking, why are arrays so useful?
Organization, basically.
It's organization, but it gives us the ability to use a formula to point to each item and say, I want to access this item this time. And on the same line, the same expression, the next time I can say, oh, I want to refer to that one. Because I can change the variable inside the formula.
Easier to control.
Very easy to control. It gives you a lot of flexibility. Okay, so that's the end of today's class. I'll see you guys on Thursday, and we'll continue the topic of arrays. So go ahead and read ahead of me if you have time.
So what's an array, Mike?
Sorry?
What's an array, Mike?